Hi folks, welcome to another video. Today we're going to be solving radical equations. This goes with section 7.6 in your Algebra 2 textbook. And the objective of today is we're going to solve radical equations and we're going to solve rational exponent equations. And we're going to see exactly what that means. I'm going to see how to do that. I do want to start by saying, or just stating what you already see on your page here. The key step when we solve these radical equations is we're going to raise both sides of the equation to the same power. So that's really the new thing for us. Everything else that we do is really the normal algebraic techniques of unwrapping, but we're going to be raising both sides to the same power. So that's going to be the new step for us there, guys. Okay, so let's take a look at a nice little example here. We're going to solve this rational exponent equation. And I'm really just going to do the normal process that we think about unwrapping. I see that there's this -4 over here along with my variable. I want to get that on the other side. So I'm going to add 4 to both sides. And I'll have the cube root of x is equal to 5. Okay, now let's think about this a moment. I want to unwrap this cube root of x. So I want to think of, well, what's the opposite operation? What's the inverse operation that unwraps cube rooting? Well, cubing will unwrap cube rooting. So I'm going to cube both sides. I'm raising both sides to the third power. So when I cube both sides, look at what I get here. Well, when I cube a cube root, I get back what I started with. I get back x. And on the right side, I get, well, I get 5 cubed, which is 125. So let's take a look at what I did a little more formally. Well, the first thing I did, going from my first step down to my second step, was I got my variable by itself. I isolated a radical, and then I unwrapped it. Right? I raised both sides to the third power. So here's a little more formal way of saying this. The first step, I isolate a radical, whatever that takes. Sometimes it's already isolated. Sometimes we need to add or subtract, get a radical on one side of the equation by itself. And then step 2, this is our new step for us right here. I raised both sides to the reciprocal exponent. That's a fancy way of saying, okay, I was cube rooting x. I want to cube that in order to get rid of the cube rooting. So those were the first 2 steps I did. I didn't have to repeat. This is not normal. Pardon me. I get my thing going. This is not normal. We're going to see one problem at the end here, really just for the honor students, where we're going to have to do this process more than once. But that third step, the repeating process, really is not normal. And then sometimes we have to solve by previous methods. On the more complicated problems, we'll have more to do after we either cube both sides or square both sides or raise both sides to the 2/3 power. There might be a little more to do, so we might have some previous methods to consider. And the last thing I want to say on this page is, you guessed it, watch out for extraneous solutions. We're going to take a look at what they are. We've seen them before, but we should really just kind of remind ourselves what extraneous solutions are and know that we're going to get them sometimes. Okay, let's look at a second problem here. So when I take a look at this, I notice that, there's only one term with the variable. So when I have that, just like previously in our algebra techniques, I just want to unwrap here. I just want to do the inverse operations and get x by itself. So I'm going to do just that. So I'm going to just rewrite this. And when I look at this, I notice that the multiplying by 2, that's the last thing that happens to my variable term. So I'm going to divide both sides by 2. Now I'll have x to the 3/2 equals 125. Okay, so now I have my variable by itself. I now want to unwrap that exponent. Well, let's think about what we want to end up with here. We want to end up with an x to the 1 power, right? Equals some number. Okay, so how do we make that happen? Well, I'm going to raise both sides Well, 3 halves times what gives me 1? Well, that's the reciprocal of 3 halves, or 2/3. So I'm going to raise that to the 2/3, which means I need to raise my right side to the 2/3 as well. And that's how I get this x to the 1 down here, because that's what I want to end up with. I want to just get x by itself. So that does that for me on the left side. And now I need to figure out what the cube root, I'm going to do a little side work here. The cube root of 125 and then squared is. Well, the cube root of 125 is 5. So that's going to be 5 squared, or that's going to be 25. So I get x is going to be 25 in this case. Okay, let's look at another problem. This one's got a little more involved in it. So I have more than just one x, right? I have an x over here. I have an x over here. So I really need to hold on one second for a moment. Okay, sorry about that as I gather my thoughts here. So again, I have multiple terms with x's in them, but what's nice about this is all located inside a radical. So I'm really just going to unwrap that right side. I'm going to go through my steps here. I'm going to isolate a radical. Well, this radical is already by itself, right? That square root of negative x plus 8 is already on the left side. Nothing else is over there. So I'm going to unwrap that square rooting, which means I'm going to square both sides. So I'm going to square that whole thing, and I'm going to square this whole thing. Well, the left side is really nice. I'm square rooting and then squaring. I'm going to get back exactly what I started with. I'm going to get back that radicand. The right side, you have a little work here. Remember, this is really saying x plus 4 times x plus 4. That's not just x squared plus 4 squared. I actually need to FOIL that out. Right? We have our square, double square. And you can check this if you like. But I get x squared plus 8x plus 16. So I've isolated a radical. Well, that was already done for me. I squared both sides. I got rid of the radical itself. And now I'm going to solve by previous techniques. I now have a quadratic function here that needs to be solved by techniques that I already know about. So I'm going to bring everything to the right side. I'm going to add x, and I'm going to subtract 8. I'm going to add x. I'm going to subtract 8. I'm going to get 0 equals x squared plus 9x plus 8. And now this is a quadratic that, as it turns out, is factorable. So I'm going to go ahead and factor this. X plus 8 times x plus 1. And because these are being multiplied and I get 0, I can split these up to x plus 8 equals 0. Or x is going to equal negative 8. And for my second factor, I get x plus 1 equals 0. Or x equals negative 1. Now, I'm going to go back a second here to this previous page and just point out again that we need to watch out for extraneous solutions. This happens more often than you might think with these problems. So I get these two solutions down here of negative 8 and negative 1, but I need to make sure that they work in my original problem. So I need to go and plug them back in. Well, I'm going to rewrite my original problem here. I'm going to go back up here and just make sure I see what it is. In fact, I'm just going to make some room here and do it right below it. And I'm going to substitute in, well, let's try negative 1 first. So I'm going to do the square root of the negative of negative 1 plus 8. And does that equal negative 1 plus 4? Well, this is really, see, I can cancel these negatives here. So this is really 1 plus 8 is 9. This is really the square root of 9. Well, we know that's 3. And negative 1 plus 4, that's also 3. So that works. We know that negative 1 is a solution. I'm going to keep that. Not a very formal way of saying it, but I'm going to keep negative 1. Okay, now I'm going to test negative 8 and see if that works. And now I'm going to do that right below it. I don't need this other stuff here. And I have negative of negative 8 plus 8. Does that equal negative 8 plus 4? Well, let's see, again, I can cancel these negatives here. I have 8 plus 8 is 16. Square root of 16 is 4 on the left side. And the right side, well, we get something a little bit different here. I get negative 4 from this. Well, negative 4 doesn't equal positive 4. So 8 is not an answer. I'm going to cross this out down here. Negative 8 is not a solution that's going to actually work in the original problem. That's what we call an extraneous solution. A solution that we get algebraically, but doesn't actually work in the original problem. So I'm going to keep negative 1. I'm going to say negative 8 is extraneous. To be a little more formal about it, I'm going to write it like this. Negative 1 I'm going to put in curly brackets like that. And to show that negative 8 is extraneous, I'm going to put in parentheses like that. It's not overly necessary that we really nail down this part here, but you should at least be able to identify which answer is one that we're going to keep and what answer is one that's going to be extraneous. Sometimes they're both extraneous. Sometimes we keep them both. Sometimes we get a situation like this where one we keep and one is extraneous. So you really got to check all of these and really and kind of really be on your game with this. Okay, so before we go on to the next problem, I just want to point out why we got an extraneous solution. And it's really kind of a simple idea in this case, at least. So let me start off with two numbers here, 2 and negative 2. And we know those are not equal. Okay, so those aren't equal. Okay, so think about what we did. Well, we squared both sides of the equation, right? So if I square both sides here, what happens? Well, I get 4 on the left and I get 4 on the right. Well, those are equal. So at the end down here, where we had x equals negative 8 and x equals negative 1, we got that because we had squared both sides, and we kind of glossed over this idea that x could have been, or that our one or both of these sides could have been negative, and they really can't be, right? Because this left side here has to be a positive value, right? So I'm taking the square root of something, right? So that's why we get an extraneous solution sometimes, or multiple extraneous solutions, and we should just be aware of that. Okay, let's look at one or two more. This time we're going to have a radical on both sides. And this does clean up pretty nicely. There's a little, not catch here, but something you should look out for. We're going to see it right off the bat here. So let's go down our list. Do we have a radical isolated? Well, yes, we do. This right side, we have a radical isolated. Even the left side, I guess we can say we do, even though that 3 is out there. But we definitely have at least one radical isolated. Okay, so I'm going to unwrap that. I'm going to square both sides. And here's the thing you got to look out for right off the bat. This 3 is also being squared. So I'm going to get 9 times x minus 4, right? When I square that square root of x minus 4, I just get back x minus 4. And again, that 3 also gets squared. So that's a little catch on this one. And that's going to equal, on the right side, we get x plus 2. And now we're down to really a nice little linear equation. Sorry that this keeps popping up. I try to get rid of it, but it doesn't seem to go away. So I can go ahead and solve this by previous methods. And really, this is hopefully no big deal at this point in time. I can subtract x. I can actually add 36 at the same time. So on the left side, I get 8x. The right side, I get, looks like 38. And a little division here, clean this up a little bit. And I get whatever 38 over 8 is. Looks like I can simplify that a little bit. At least I can divide by 2 and say that this is going to be, what, 19 over 4. And again, I should check that. I'm going to leave that up to you, just because I want to make this video as concise as possible here. But we did square both sides. This deserves a check. But we're going to move on to another problem. Okay, so one more here. So slightly different problem. Not too different, but slightly different. In fact, this is a lot like the one that we started off with, but there's a little more going on inside the cube root here. So again, I have a radical. It's a cube root, but I do have a radical. So I'm going to isolate it. I'm going to add 1 to both sides. So I'm going to get the cube root of what ends up being 4x plus 28 equals 4. And again, I want to think about inverse operations. What can I do that unwraps cube rooting? Well, that means that's cubing, right? I'm going to cube both sides. So when I cube both sides, on the left side, I get back what I started with. I get back that 4x plus 28. And on the right side, I get, well, 4 cubed is 64. So again, with a, it starts off looking, rather maybe not so nice up there, but really just 1 or 2 moves here, I get this down to a pretty simple linear equation, which I can go ahead and solve and put a finish on this problem. And what do I get here? So it's 36 maybe. And I can divide by 4. And it looks like I got x equals 9. And again, I'm going to go ahead and check this. A little secret, I really don't need to because I cubed both sides, and that's not going to make anything that was negative into a positive. But I'm going to check it anyways, just so we can see a check going on here. So I'm going to do the cube root of, 4 times 9 is 36, plus 28, subtract 1, and does that equal 3? Well, 36 and 28, that's going to be 64. Cube root of 64, well, that's 4. And 4 minus 1 is 3. Yep, that works. So it is worth checking, again, or at least knowing how to check some of these, and just to make sure that we have our valid answers. Okay, so just a little wrap up here. Just to make sure we know what we talked about today. We solved some radical equations, and we solved rational exponent equations. Our basic techniques were we isolate a radical, we raise both sides to the reciprocal exponent. Again, if we had a square root that we were unwrapping, we squared both sides, right? We want to do the inverse operation. We didn't actually do any of this repeating, right? Again, those are going to be for the honors classes, so you guys have another video to watch on repeated roots, or repeated unwrapping here. And then we solve by previous methods. Again, you might end up with a quadratic, and you need to possibly factor or maybe use quadratic equation or some other techniques like that. And again, something to watch out for, well, we get extraneous solutions along the way. So you need to be cognizant of that, and you need to know how to check for that as well. So I hope you enjoyed this lesson. Take care and have a great day.